Good morning again, students. This is lesson 1-1 and 1-2. I'm going to be going over for the first two lessons in summer school. Okay, let me go ahead and screen share here so you can see lesson 1-1. All right, lesson 1-1, variables and expressions. Okay, the objective is to write an algebraic expression. First, I just want to quickly go over the vocabulary. The word quantity is anything that can be measured or counted. Some quantities remain constant, change, or vary, and they are called variable quantities. What I mean by variable quantity is a quantity or just an amount of something, okay? For example, the amount of pairs of shoes that you have in your closet, okay? That could be a quantity, but that quantity could change. It could change, for example, if you needed another pair of shoes because you're going to a quinceañera or something like that. So then the quantity would increase. But other quantities are fixed numbers, okay? And a fixed number is what we call a constant, meaning a number that just is that number, okay? That number could be like, for example, the number of moons that the Earth has. The Earth has one moon, okay? That's a fixed number. Now, some people could argue, well, the satellites are like little tiny electronic moons, but that's not, specific enough, and that's, yeah. So the idea is a constant means a number like 2 or 5 or 7 or 8, okay? A variable means a number that can change, and they're usually represented by a letter like F or Z or I. The most common one to use is X, okay? Continuing on, variable is a symbol, usually a letter that represents the values of a variable. An algebraic expression is a mathematical phrase that includes one or more variables. A numerical expression is a mathematical phrase that includes involving numbers, operations, and symbols, but no variables. To translate words into phrases into algebraic expressions, look for words and describe their mathematical operations. Okay? Now there's a little thing here on operations I want you to look at in the book. And by the way, this is page 4, in case you can see the page number there. But I'm going to go ahead and jump to notes right now. Okay? So lesson 1-1 is on variables. Okay? And I want to go over different categories of variables. Now again, for our purposes, we could say a variable is a letter. But it's a letter that's used in a math problem, and it represents a number, usually an unknown number. Okay? Now there's 3 basic categories of variables. The first one, usually when the variables A, B, and C, and so on, that represents numbers that are in sequence. Like, for example, A would be the first number, B would be the second number, C would be the third number, D would be the fourth number, okay? Now, I want to make something clear. It doesn't mean that every time you see A, B, or C in a math problem that it is always going to be numbers in sequence. Sometimes a variable is just a placeholder for a number, okay? But I'm just saying usually, okay? I want you to be clear that usually when we see A, B, or C, then that means numbers in order or numbers in sequence. Now, there's the very common X, and then usually almost as common as Y, and sometimes you have Z. When you see X, Y, and Z, usually these are numbers that are related to graphing. Later in the course, we're going to find out a lot about how to graph numbers on a coordinate plane or on graph paper, okay? That's when you use the letters X, Y, and Z. Now, certain variables like M, or I, P, and R, where certain letters represent specific values in a formula, okay? Now, a formula basically is a specific type of equation that represents something that is always going to be true. Now let me give you an example. A equals L times W. A equals L times W. A stands for area, L stands for length, and W stands for width, or wide. I should probably write the correct word. Now, this particular formula, A equals LW, L times W, represents the formula for the area of a rectangle, okay? So the area of a rectangle, A equals L times W, the letters that are used actually represent actual values. Now you'll notice that the first letter A is the first letter of area. The letter L is the first letter of length, and the letter W is the first letter of the word width. Okay? Now in this formula, every rectangle might not have the exact same length and width, but every rectangle can be measured by the formula A is equal to L times W. So that was just one of the things I wanted to show you. Now some letters, like M, can represent a couple of different values. It can represent something that starts with the letter M, but it usually represents either an angle or it represents the value of something called slope, which we'll be discussing later in algebra. I, P, and R often represent the values in money of interest, principal, and rate. Okay, so I just wanted to point out that these variables are what we might call literal variables, meaning that they actually represent a specific value. X, Y, and Z usually represents graphing, and A, B, and C usually represents numbers that are in order or sequence. Okay, now for today's lesson, I want to continue by talking about the different types of ways that we use numbers in expressions, okay? Numbers and variables. Now, first I wanted to talk about what is the answer in a given math problem. Now, in math, there are 4 different operations that we go by, okay? They are addition, subtraction, multiplication, and division, okay? So the answer for an addition problem is called the sum. I want you to memorize this. The answer for a subtraction problem is called the difference. The answer for a multiplication problem is called the product. The answer for a division problem is called the quotient. And since algebra uses all of those at different times, the answer for an algebra problem is called the solution. Okay? So I just wanted to again go over those before I go over how we can talk about different expressions. Now I have an expression here. It is 5 plus x, or 5 plus the letter x. Now, let me say some different ways that I can say this using words. I can say 5 plus x is the sum of 5 and x, or I can say that it is x more than 5, or I could say that 5 is increased by x. Now, I need you to pay attention to something very carefully. The order of the expression from left to right. 5 plus x. Now, in the first sentence here, it describes it as the sum, meaning the answer of 5 and x. Now, do I know what the answer to 5 plus x is? No, not unless I can come up with an actual number that x means, okay? So the sum of it is going to be unknown. So in the first sentence, I'm saying the sum, or the unknown answer, of 5 and x, okay? Now in this case, they stay in the same order. 5 is first and x is second. But look at how the language changes when we go to the second one. So I have 5 plus x, but here I say it is x more than 5. The order changes, okay? So you need to be careful. If you come up with something that says x more than 5, a lot of people might say x plus 5, okay? But more than implies that 5 comes first and that x is being put onto it or added to it, okay? Or summed up with it. So the idea is if you have a sentence like this, x more than 5, then the thing that's more than should come after, and you should write it like this: 5 plus x, because the x is being added on to the 5. It's increasing it. Which brings me to the last number sentence. 5 increased by x, okay? So in this case, because we use the past tense ed with the word increase, then I can still have it in the same order. 5 increased by x. But if I could also say in the other order, x increases 5. Okay, in that case, I would still write the 5 first. And the reason I'm spending a lot of time on this is because the wording can sometimes get very complicated when you have these types of problems. And with addition, it's not so much, because if I say 5 plus x, or if I say x plus 5, these two expressions are equal to each other. But with subtraction, that's not always true. Okay? Let me give you an example. 7 minus 2 is equal to 5. But if I say 2 minus 7, that's equal to negative 5. Okay? So these are not equal, these two expressions. Okay? They are not equal to each other. So the order is very important, especially when you get to expressions that have subtraction problems. Let's take a look. I'm going to go back to the book here. I'd just like you to see some of the sample ones. Again, we're on page 4 if you want to look over these on your own, because I'm going to go over them fairly quickly. Okay, subtraction, the words that mean it are difference, minus, less than, and decreased by. We have the expression n minus 7. Okay, the difference of a number n and 7. Okay, again, it's using the word difference, meaning the answer in a subtraction problem. 7 less than n. Now you'll notice the order changes in the word sentence. 7 comes first and n comes second. But if you write it as 7 minus n, you would get the absolute wrong answer, because it's n minus 7. Okay? Remember, if it says more than or less than, then whatever is first is usually written second when you put it into expression form. Okay? Because the idea is that n was the original number, and then 7 does something to it. In this case, takes away from it. Okay, a number n minus 7. In that case, the order is correct. So pay very careful attention to the wording. If it says more than, like in this one, or less than, like in this one, then that usually implies to switch the order when you write it as an expression. Now let's take a look at multiplication and division. With multiplication, I have 4 times y, and then 4 times y, and I have 4 right next to y. Anyways, just wanted to point out, if you have a number next to a letter, that automatically implies multiplication. Okay, so that is the product of 4 and y, and 4 times a number y. In this case, the order is not changed in how it is in words. Now with division, there's usually 2 ways to write it. I have n divided by 2, or written as a fraction, n over 2. I also have n division symbol 2, or n divided by 2. The quotient of n and 2, or n divided by 2. Now in this case, both of them seem to imply the right order, but just watch them very carefully, okay? Because order does matter, especially with division and subtraction. With addition and multiplication, the order doesn't matter. With subtraction and division, the order matters completely. You will get the wrong answer if the order is off. Okay? Now, in just a couple minutes, we're going to go to lesson 1-2. I'm going to get ready for that, and I'll talk to you in just a minute. You can pause the video right now and start your homework. Hello, I want to continue with our lesson, and we're going to go to chapter 1-2, part 1, which starts on page 11. Let's go ahead and take a look at that. Now, this lesson is on order of operations and evaluating expressions. The objective is to simplify expressions involving exponents and to use order of operations to evaluate expressions. Okay, first I'll just go into the focus question, how to simplify an expression with an exponent involved multiplication. You can use powers to shorten how you would represent repeated multiplication. Now in this case I have 2 times 2 times 2 times 2 times 2 times 2. Now when you're multiplying the same number times itself, then every time that you multiply it, since it is being multiplied by itself, can be written in a different way. And that would be called writing it as an exponent. Okay? So instead of writing 2 times 2 times 2 times 2 times 2 times 2, I would write 2 to the power of 6. Now let's go ahead and read this. A power has two parts, a base and an exponent. The exponent tells you how many times to use the base as a factor. You read the power 2 to the third power as 2 to the third power, or 2 cubed. Cubed is a nickname for the exponent 3. You can read 5 with a little 2 as 5 to the second power, or 5 squared. Squared is a nickname for the exponent 2. Now, if you take a look, I'm going to try to zoom this in a little bit here so it's easier to see for you. Hoping that's not too blurry. Now, again, of course, you can look on page 11 in your book. But the base is the large number that, when I say large, not in numeric value, but literally that you draw it larger. The exponent is the small number that is written up to the top right of the large number, the base, and that's called the exponent. So 2 to the third power means 2 times 2 times 2. Together, it can be called an exponent or it can be called a power. Okay? I'm just going to close the window because someone's driving kind of fast. I don't know if you could hear that. You simplify a numerical expression when you replace it with its single numerical value. For example, in the form 2 times 8 is 16. To simplify the power, you replace it with its simplest name. For example, 2 to the third power, or 2 cubed, would be 8. Okay, let's follow that. 2 times 2 is 4, times 2 again is 8. So I'm holding up 3 fingers, so that would represent the 3 2's, or 2 to the third power. So 2 times 2 times 2 equals 8. Okay. I hope you're following me with that. Let me jump to my paper here. And as you can see, here's the previous lesson. Let's jump to the second lesson here on order of operations. Just trying to get used to working with the camera here. Let me move this so it's, sorry, a little bit more clear. Okay, order of operations. Order of operations, the order of operations basically tells you what you are supposed to do first when you have a group of things together. Now I'm just going to put some random numbers and operations in line here. 2 plus 7 times 4 minus 3 plus 2 squared. Okay? Now, generally speaking, I look at this problem and I think, I have an expression and I want to do the answer to it from left to right. Okay? So I would say 2 plus 7, and then that answer times 4, and then that answer minus 3, and then that answer plus 2, and then everything to the power of 2. Problem is, if I do it the way I just said, I'm going to completely get it wrong. Okay? Order of operations says I must do certain things first. Now, you may have heard probably in 6th grade or 5th grade the expression PEMDAS, which stands for Please Excuse My Dear Aunt Sally, which also stands for parentheses, exponents, multiplication, division, addition, and subtraction. Okay? So that is order of operations. Now, I like to use the word powers instead of exponents, but everyone has a preference. But they are parentheses, powers, multiplication, and division, which I want to remind you is considered really one category in order of operations, with commas in between everything, addition, and subtraction, and all of it from left to right. Okay? Meaning that each particular part is done from left to right. So if I have parentheses or other grouping symbols inside of a math problem, I work within it from left to right. Okay? If I have more than one exponent in an expression, I want to do the left ones first and then go over and do the ones to the right. If I have addition and or division in a problem, then I do it from left to right. If I have, did I say addition? I meant multiplication in case I accidentally said that. If I have addition and subtraction, I do that from left to right. Okay, so each category is done from left to right. So let's take a look at our problem. First, I want to see parentheses, but in this expression, there are no parentheses. Let's see, powers. I do have a power right here. Okay, 2 to the power of 2. So that means 2 occurring in a multiplication problem 2 times. So 2 times 2. Now, I don't want to confuse you. A lot of people look at exponents and they say, I take the base and I multiply it times the exponent. No. You take the base and you multiply it by how many times the exponent says to do it. Now in this case, since the exponent is 2 and 2 times 2 happens to equal 4, unfortunately you can do this one wrong and still get it right. But regardless, the answer for this is 4. And I'm only crossing it out because I have figured out the answer to it. Now let's take a look. So there were no parentheses. I did the power. 2 to the power of 2 equals 4. Now I do any addition and division. I said addition again, I meant multiplication. I don't know why I'm making that mistake a lot today. So there's multiplication here. So before I add or subtract anything, I must go ahead and multiply. So 7 times 4 equals 28. I'm only crossing that out because I have finished that part. Okay. Now, the next part of order of operations is addition and subtraction from left to right. So I now have addition to that, then I have subtraction. But the leftmost thing that I have is the addition, so I want to do that first. So 2 plus 28 would be 30. 30 minus 3 would be 27. So now I can cross those out, and I have 27. Now, the only thing that's left is 27 plus 4. Okay, because remember, 2 to the power of 2 is equal to 4. So 27 plus 4 equals 31. So this expression equals 31. Now, if we were to do it out of order of operations, would we get 31? Let's go over it. 2 plus 7 is 9. 9 times 4 is 36. 36 minus 3 is 33. Plus 2 is 35. And 35 to the power of 2 is, I don't know, probably like a lower 1,000. I'm not exactly sure. I can figure it out. 35 squared means 35 times 35. Let me move the camera here just so you can see. 5 times 5 is 25. 3 times 5 is 15, 16, 17. Put a 0 as a placeholder to show that I'm done there. 3 times 5 is 15. Cross that out. 1 there. 3 times 3 is 9. Plus 1 is 10. 7 and 5 is 12. 1 plus 1 is 2. So the answer is 1,225. 1,225 is not 31. So there's my point. If you do it out of order of operations, then you're likely to get a wrong answer. Now, you could mess up order of operations a little bit and sometimes still get the right answer depending on the problem and depending on which part you messed up. But the idea is to know it well, and it again is parentheses, powers, showing strength there, times and divide. I use the fraction bar here for divide, plus and minus from left to right. Okay? So please memorize order of operations. Last thing I want to say on this lesson is expression, group of numbers, variables, and operations. An equation is two expressions connected by an equal sign. Okay? You can also think of it as an expression as a number sentence and an equation as a number sentence that also contains an equal sign, just to show how they are different. Okay, hopefully that is helpful to you. You should go ahead and do lesson 1-2 now, and then I'm going to make a separate video for lessons 1-3 and 1-4. Thank you very much.